So in this video, we're going to talk about how to simplify rational expressions. So remember we talked a long time ago about how to simplify fractions, right? Remember you look for the GCF of the number that's in the numerator and the denominator. So the GCF, the greatest common factor of 36 and 54, will be 18. So we'll factor out an 18 from both of these numbers. So in the numerator, we have 18 times 2, and then in the denominator, we have 18 times 3. So now you can see that this common factor of 18 will cancel, so this fraction will reduce to 2 over 3. So we're going to use a similar idea to go ahead and simplify rational expressions. So when we simplify rational expressions, we're going to factor the numerator and denominator. Remember to always look for a GCF first. Then we're going to cancel any common factors. So let's look at some examples. Let's simplify 3x squared plus 12x minus 36 over 6x squared minus 24. So it's helpful to look at the numerator and denominator separately. So let's look at 3x squared plus 12x minus 36. Notice that there is a GCF to these three terms, right? I can factor a 3 out of all three of these terms. So that leaves me with 3x squared over 3 plus 12x over 3 minus 36 over 3. So now when I simplify this, I have 3 times here, 3 and 3 cancel, so I have x squared. And then I have 12 divided by 3, which is 4, so 4x. And then minus 36 divided by 3, which is 12. So now let's go ahead and factor this trinomial we have left, right? X squared plus 4x minus 12. So I have negative 12, and I need two factors of negative 12 that are going to add up to 4. So when I have negative 12, I'm going to have a positive factor and a negative factor. Since 4 is positive, I'm going to make my bigger factor positive. So I have 1 and 12, and I have 2 and 6, and I have 3 and 4. So you can see the pair that adds up to 4 is negative 2 and 6. So I'm going to use those as my factors. So this is going to simplify to 3 times, right, because 3 is the GCF. So we have x minus 2 times x plus 6. So that is the fully factored numerator. Now let's go ahead and factor the denominator. So we have 6x squared minus 24. So now let's look for the GCF. So notice that these two terms are divisible by 6, so we have a GCF of 6. So we're going to take 6x squared minus 24. We're going to factor out a 6, so that means we're going to divide every term by 6. So when we do that, we have 6 times, and then the 6 and 6 cancel, and we have x squared minus 24 divided by 6, which gives me 4. So notice this x squared minus 4. That is actually the difference of two squares, right? So that is basically 6 times like x squared minus 2 squared. Well, remember we have that special pattern that a squared minus b squared equals a plus b times a minus b. So we can factor this as 6 times x plus 2 times x minus 2. So now we have the fully factored numerator and we have the fully factored denominator. So now let's rewrite this expression. So we have 3 times x minus 2 times x plus 6 over 6 times x plus 2 times x minus 2. So what we're going to do now is we're going to reduce this fraction, right? So you can see here this x minus 2 and x minus 2 will cancel, and then 3 and 6 will reduce, right? So this will leave me with 1, and then 3 goes into 6 2 times. So that basically leaves me with x plus 6 over 2 times x plus 2, right? That is my final simplified form of this rational expression. So let's determine the restricted domain of the rational expression and simplify 40x squared y to the fourth over 5x cubed y. So here we just have two monomials. So we'll just go ahead and simplify what we have. So we have 5x cubed y. So 40 over 5 will reduce, right? So 40 divided by 5 gives me just 8. So I'm going to have an 8 in the numerator, and then that's just going to be a 1. So I have 8, and then in the numerator I have x squared, the denominator I have x cubed. So I can basically factor an x squared out of both, right? If I divide this by x squared, that's going to leave me with just 1. And then here, that's going to leave me with x, right? Because x times x squared is x cubed. Here I have y to the fourth and a y, so I can divide out a y from both terms. So I have y cubed, and the denominator is just 1. So if I figure everything out, I have 8 times 1 times y cubed. And then in the denominator, I have 1 times x times 1. So that is just going to basically simplify to 8y cubed over x. And that is the simplified rational expression. So now it wants us to figure out the restricted domain. Restricted domain basically means that some values are not going to be included because they make the denominator equal to 0. So to figure those out, we're going to say 5x cubed y. We're going to set it equal to 0 and figure out what values make the denominator 0. Well, we can go ahead and divide everything by 5 because that's just a constant. So that leaves me with x cubed y equals 0. So that means that either x cubed equals 0 or y equals 0, right? Because we have that 0 product property, which says that if two things multiply to equal 0, that means that either a equals 0 or b equals 0, right? You can think about that. The only way to multiply two numbers and get 0 is if one of them is equal to 0. So y equals 0 is one solution. We also have x cubed equals 0. So to solve that, we can just take the cube root of both sides. And we do that, we get x equals 0. So that means that's going to be our restriction. We're going to say that x does not equal 0, and we're going to say that y does not equal 0, because those two values will make our denominator equal to 0. So let's determine the restricted domain of this rational expression and simplify. Well, the nice thing about this rational expression is that it's already been factored for us. Okay, so if it's already been factored, you just need to look for the common factors and go ahead and cancel them. So we have an x minus 1 that will cancel. So the simplified expression is going to be x plus 4 over x plus 2. So we also need to figure out the domain restrictions. When you do the domain restrictions, you want to do it on the original expression. Okay, so we're not going to look at the simplified one. You always go to the original, and then you just set the denominator equal to 0. So when we do that, we have this. We have x plus 2 times x minus 1 equals 0. So that means that either x plus 2 equals 0 or x minus 1 equals 0. So we can solve this by subtracting 2 from both sides. So that means x equals negative 2. If we add 1 to both sides here, we get x equals 1. So that will be our restriction, right? We'll say that x does not equal negative 2 and x does not equal 1. So that is our restriction for this problem. So now let's figure out the restricted domain of the rational expression g squared minus 2g plus 1 over g squared minus 1, and let's simplify it. So I'm going to start off by simplifying the numerator. So I have g squared minus 2g plus 1. So you can see I need two numbers that multiply to 1 that add up to negative 2. Since 1 is positive, and to get them to be negative 2, I need to make them both negative. So my factors will be negative 1 and negative 1. So that equals negative 2. So when I write this out, my factored form is going to be g minus 1 times g minus 1. That's my fully factored numerator. Now let's factor the denominator. We have g squared minus 1, which you may recognize this as the difference of two squares, right? This is the same thing as g squared minus 1 squared. So I can write this as g plus 1 times g minus 1. So when we write the factored rational expression, it's going to look like this. It's going to look like g minus 1 times g minus 1 over g plus 1 times g minus 1. So one of these g minus 1's is going to cancel, right? Because we have that common factor, and that equals g minus 1 over g plus 1. So that is the simplified form of our rational expression. Remember, in order to figure out what the domain restrictions are, we're going to set the denominator equal to 0 and solve. So our denominator is g plus 1 times g minus 1 equals 0. So that means that g plus 1 equals 0 or g minus 1 equals 0. So we can subtract 1 from both sides. So that tells us that g equals negative 1. And then we add 1 to both sides, which tells us that g equals 1. So that means that those are our two restrictions. G does not equal negative 1 and g does not equal 1. So now go ahead and pause the video and try this example on your own. So in this problem, we're going to go ahead and factor both expressions. Notice that the numerator has a GCF of 2, so we're going to factor that out. And then once we factor it, we factor the remaining trinomial, which gives us 2 times x minus 3 times x plus 5. If we look at the denominator, it has a GCF of 4, So we factor that out, and then we factor the remaining trinomial. So we have 4 times x plus 2 times x plus 5. So when we write this all together, you'll notice that this is our rational expression. So the 2 and 4 will reduce, so we have 1 over 2, and then the common factor of x plus 5 will cancel. So we're left with x minus 3 over 2 times x plus 2. If we set this original denominator equal to 0 and solve for the values of x, we get x equals negative 2 and x equals negative 5. So those two values will be restricted from our domain. So remember that you can simplify rational expressions by factoring the numerator and denominator. Remember to always check for a GCF. Then we're going to cancel any common factors and use that to simplify our expression.